Welcome. Now we will present the second stage of design in the vaccine transport project. We will expose at first the context in which the project will develop as the impact population needs transport considerations, among other points, followed by restrictions and requirements in which we have worked and have to continue working in this project. The third point in the development of the second sprint, the host of quality and the analysis of evolution of our device. In fourth place, we will see the current concept in the virtual presentations like CAD modeling. Finally, we will talk about our future planning for the concept and steps to be followed. We have felt the need to transport the vaccine Sputnik 5 to the elderly population in Manaure, which is located in the north coast of the country and will not have vaccination locations for its people. So to have the vaccines there, we have to put emphasis on the temperatures and transport times, because as you can see, there are relatively high temperatures around 30 degrees, and transport times can be approximately 2 hours by car. In this section, the requirements and restrictions of the problem are defined, as the ranges we established that the concept must achieve and which variables are necessary to be optimized. Some restrictions are the budget, range of temperature, maximum size of the product, vaccine size, control system, and mode of transportation. On the other hand, some variables to be optimized are volume, weight, capacity, and power consumption. Some are oriented to be maximized and others to be minimized depending on our necessities. In the house of quality, we have qualified the requirements and the restrictions of our design numerically, to be able to quantify the important aspects and generate an order of priorities. We established that number 1 is low correlation, 3 is medium, and 9 a high correlation. Using this methodology, we have concluded that the volume and weight represent the highest scores and are defined as a priority for the design. Additionally, that the lifetime and control are the less relevant in our case, since the cooling system already ensures the necessary temperature ranges, and the majority of the materials are plastics, which already count with a long lifetime.
Now the normalized indicators which were used in this sprint. These were established from the architecture of our device and were divided in 4 modules, which are structure, thermal isolation, cooling source, and control. We use numerical variables from 0 to 1, considering the importance in order to compare 2 of the models we had for us to choose the best one. Development and evolution of the concept. Below are presented the iterations performed before reaching the final concept within the things that were changed or improved. Some of the most important aspects were the complexity of manufacturing, material changes, and cooling systems. Final concept and technical specifications. In the table shown are the specifications of the final concept, which were directly tied to the restrictions and requirements mentioned throughout this presentation. The value of the mass minimized was 15.8 kilograms, and the minimized outer volume was 95.14 liters. These parameters were defined thanks to the use of Inventor. We obtained as well a capacity of 4,012 doses, a time of 28.3 hours, and an electricity consumption of approximately 2.69 watts. Of the mechanical resistance, the deformations are not significant and don't reach the plastic region. Finally, it's important to mention that all components can be reused. The CAD model. The red component is external coating, the black component is the shock absorbent system, and the last image presents the isolation piece, the closing seal, and cooling. In this model, the selection of materials was made additionally, adding the requirement of structural integrity using a vibration isolation foam, which fulfills both the function of absorbing vibrations and also being an extra layer that provided a thermal resistance. And for improving isolation, a hermetic seal was added. Steps to be followed. Improving the evolution of the prototype design by using the virtual models and simulations, followed by manufacturing a medium-high resolution prototype and harmonization tests, which helps the group to make more organized and justified decisions. Finally, for the ending of this sprint, the group will manage payment and shipping time of the components. In the case of those purchases cannot be made, we will generate and have the buying orders ready.